Hi friends, welcome back to our video series Data Structures and Algorithms. Today we are going to see what is the A-star algorithm. A-star algorithm is a very popular method that we use to find the lowest or the shortest path from one point to another point. So this method is used widely in the real life and while we develop the games. So for example, if you are playing a survival game or a first person shooter game, so there could be situations where you want to escape from one location to another location. So there could be different paths that is available so that you can reach from one location to another location. So how you find which is the least costly way to reach from one position to another position, or the easiest path or the shortest path from reaching from one location to another location. So for that we use the A-star algorithm. So when you use A-star algorithm, there are two parameters this algorithm uses to find the shortest path. One is the cost of reaching one particular location, or there could be different points when you want to reach a destination. So for example, if you are traveling from Mumbai to Delhi, so there could be different location in between that, like Ahmedabad, Bhopal, or they're like that, different locations that come between Mumbai and Delhi. So just like that, when you want to reach from one location to another location in a game, there could be different locations that come in between the source and destination. So the cost of reaching from one location to the next location is called the G. That value represents the G, and H represents the heuristic value. So heuristic value is the estimated cost of reaching from that particular location to the destination. So we cannot predict the actual cost of reaching from one location to the destination, because there could be different obstacles which can come while you travel to that destination. There could be walls, there could be mountains. If you cannot move in in that particular path, you have to change the path to avoid that obstacle. We cannot exactly say what will be the cost of reaching from one location to the destination, but we can use different methods to find out what could be the estimated cost of reaching from one location to the destination. So that value is called the heuristic value. The A-star algorithm uses this cost value and the heuristic value to find the shortest path from the source point to the destination point. So next we will see one example where we will find the shortest path from one point to another point using the A-star algorithm. So in this example, we are going to use a graph where you have a source point and you have a destination point, and we have the different points that using which we can reach from the source point to the destination point. So next we will see that example. So now we will see one example. So this is the graph which we are going to use. So here you can see that we have different nodes like A, B, C to H, and A is our start node and H is the destination node. So we are going to find out what is the shortest path from A to H using A-star algorithm. So A star algorithm uses the formula which I have mentioned here to find the shortest path. So here F is the sum of G and H. So G is the N is the node and G is the cost of reaching to that particular node, and H is the heuristic value from that particular node to the destination. In this diagram, you can see that we are going to start from A and our destination point is H. Whatever I have marked in this yellow background is the heuristic value of that particular node, and blue color digits which you can see in the path, that is the cost of reaching to that particular point. So we will start from A. In A, you can see that what will be the cost. So cost of reaching A. So for reaching A, what should be the cost? So it is from reaching from A to A, it is the cost will be 0. And we are going to add the heuristic value. What is the heuristic value of A? So that is 18. And we are going to add the sum here. So for A, I am getting the value as 18. So from A, you can go to B with the cost of 3 and to C with the cost of 4. So first I will calculate the value what we are going to get when we take the. So now we will see what is the cost in reaching to B and from B to the destination. What is the F value to the node B? Okay, so what is the cost of reaching B? So from A, I am going to start A to B. So for A to B, what is the cost of reaching the node B? That is 3. And what is the heuristic value of B? That is 11. So I am going to get the value of 14 there. And we will now calculate the F value of reaching C. Okay, so what is the cost? First, I will just write A to C. So what is the cost of reaching from A to C? That is 4. And what is the heuristic value of C? That is 12. So I am getting the sum as 16. So when you compare these values, you can see that A to B is the lowest value. So I am getting the lowest value A to B, because A to B my value I am getting is 14 and for A to C it is 16. So first I will consider A to B. From B, which node I can travel? So I can travel to D. Okay, so I will just calculate A, B to D. So what will be the cost of reaching from A to B? That is 3 plus cost of reaching from B to D, that is 4, plus heuristic value of D. Okay, so we have to calculate the heuristic value of the child node. Okay, so which we are going to travel. So that is the heuristic value of D is 7. So we are going to get the total value of 14 there. Okay. So for A, B, D, I am getting the value of 14. Then from D, which nodes I can travel? So that is C, E, and G and F. So these nodes I can travel from D. So first I will calculate A, B, D, and C. Okay. So what is the cost? A from A to B, it is 3 plus then B to D, it is 4, D to C, it is 8 plus heuristic value of C, that is 12. So what I am getting, that is 27. Next I will go for A, B, D and E. Okay, so it is A, B, D and E. So what will be the values? 3 plus 4 plus D2E. I am getting the cost of 6 plus heuristic value of E is 9. So I am getting the total cost of 22. Now I will go for A, B, D and G. So for A, B, D, G, I am getting the value of 3 plus 4 plus 7 plus 3. That is the 3 is the heuristic value of G. So I am getting the total of 17 here. I have one more, that is A, B, D and F. Okay, so that is I will go for A, B, D and F. So for A, B, D and F, what will be the value? 3 plus 4 plus 7 plus 4. Okay, so 4 is the heuristic value of F. I am getting 18 there. From this chart, I am getting A, B, D, so 18, 17, 22, 27, this 14. When I consider from D, from the node D, I am getting the values of 27, 22, 17 and 18. So the least value is A, B, D and G. So that is 17. But when you consider this chart, you can see that from traveling from A to C, I am getting the value of 16. So I will next explore the path of A to C. So from C, which path I can follow. So from C, I can travel to D and E. So first I will go for A, C, D. Okay, so what is the cost? From A to C, it is 4. From C to D, it is 8. And heuristic value of D is 7. So I am getting the value as 19. Next, I will consider the A, C and E. So when you want to travel to A, C and E, what is the cost? The cost is 4 plus 3 plus heuristic value of E is 9. So I am getting the value as 16. This A, C, E, I am getting the value. So this is the lowest value which I have right now. So I will follow this path. So from E, which nodes I can travel? I can travel to D and G. Okay. So I will go for A, C, E and D. So when you consider this A, C, D, E, I can go for 4 plus 3 plus 6 plus 7. Okay. So I am going to get the value 20. I will check the next one, that is A, C, E and G. Okay. So for A, C, E and G, I am getting 4 plus 3 plus 6 plus 3. Okay, so that is 16. Okay, so I am getting the value as 16 there. Now I will go from G. So from G, which nodes I can travel? Okay, so far I can travel to D and H. So I will go for A, C, E, G and to D. Okay. If I go this way, then what will be the cost? 4 plus 3 plus 6 plus 7 plus 7. 7 is the heuristic value of D. Okay, so I will get that 27. Now I will check the other one, that is A, C, E, G to H. Okay, so what will be the cost? 4 plus 3 plus 6 plus 4 plus what will be the heuristic value of H? So it is the destination, so we will assume that the heuristic value is 0. Okay, so I am getting the path as 17. So from reaching the A to H, I can take this path A, C, E, G, H. So it is, I am getting the value as 70. Okay, so if you are going to calculate this A, B, D, then F to H, then you are going to get the value as what? 7 plus 7, that is 14 plus 5. So it is greater than 17. And if you follow this path, like A, B, D, G to H, it is 7 plus 7, that is 14, then plus 4. So that is 18. Then that is also higher than the 17. So you can assume that the shortest path from start point of A to the destination point of H is A, C, E, G, H. Okay, so using this A star algorithm, we can find out what is the shortest path from the start node to the destination node. So I hope you understood how the A star algorithm is used to find the shortest path from one point to another point. So when you develop the games, you use a lot of this algorithm to find the shortest path from one location to another location. And the popular game engine like Unity uses A star algorithm to find the shortest distance from one point to another point when the character wants to move or reach from one position to another position. So in the coming videos, we will see some of the examples of how A star algorithm is used while developing games. So, and thank you for watching this video. Thank you so much.